Okay, I'm here with Dan Kammen, who is a distinguished professor of energy at the University of California, Berkeley, and a PhD in physics from Harvard, and undergrad at Cornell. And I have a few technical questions to ask Dan about the direction of alternative energy from a technological perspective. First question, Dan, what do you see the biggest technical challenge in alternative energy at the current time? Or a number of them, if there's more, well, there's more than one.
Well, I'm not sure there is much of a technical challenge. There's no question we need more efficient and less expensive solar cells and wind turbines and that sort of thing. But the real question now, in my view, is can we scale up some of the good ideas that already exist? There's a number of very attractive companies, there's some very attractive processes and patents, and for me it's really about gaining that industrial foothold so that in the second wave of research we can find out what are the real issues. I certainly think we're going to need low-cost distributed storage, and that is a huge technical problem. It's one actually that ARPA-E invested in its first round of grants. But I can't forecast yet whether 10 years from now we're going to find that we need very innovative materials for storage or whether we actually overbuild supply and worry less about storage. It's just not clear to me yet.
Okay. Yeah, that leads to the second question. I was wondering if you saw any breakthroughs in the storage. Of course, the advantage of a fossil fuel is it's concentrated, you can move it around, which isn't the case with electricity and causes difficulties with distributed generation like wind, whereas you generate it, and if you don't need it when you generate it, what happens? So what about that, what the economists call the fungible nature of electricity?
Well, I'm not actually that worried about this for a couple of reasons. One is that hydrogen provides storage and H2O provides storage. We know about pumped hydro and about large and small dams. So there are opportunities for storage today. Biofuels are a form of storage. So we have opportunities to store power right now. And because very few places in the U.S. have such a large amount of renewables in the mix, that storage is a constraint. In fact, I would argue nowhere right now is storage constrained in the United States, whereas storage is becoming an issue in parts of Denmark, for example, that if we do what we need to do, which is to continue to invest in research, we will find, in my opinion, that the storage solutions we need are ones people will want to work on. They are exciting, they're profitable, and there are really interesting issues of applied physics, of material science, and potentially of innovative mechanical systems, all of which could come out of a wave of research on storage. But I just don't see it as a constraint yet. So it is something we need in the long-term pipeline, but not something that determines what the energy markets would do today.
Okay. If you're going to look out in the future and at some point in time say, we've turned the corner, what do you think that signpost is going to be that we've turned the corner?
Well, I think it's got to be a mixture of two things. One is we have to have an innovative economy in clean energy. And that's going to mean continued research and development by universities, by industry, by utility consortiums. But we're also going to have an economic system that rewards what we want. And in my opinion, what we want is clean, secure, reliable energy. And right now, our economic systems do not reward that. So it's those two things at the same time. Then I would think we turn the corner. Then the question is, do we win the race or not? Do we get to that clean energy future before we disrupt either national security or the global climate so much? But it becomes a race, whereas right now I'm not even sure we're fully on the right path.
Okay. Last question. What's your current favorite success story from a technological standpoint? You talked about a number of things in your speech. Are one of those, or is there a favorite that you like to talk to people about?
I mean, I think that the real lesson from renewables is that there's a diversity of technologies that are doing pretty well and that we need. So I'm not sure I have a favorite technology. I do certainly like seeing what's happened in the wind industry. Where wind goes, it's not clear, but the fact that when wind was being deployed only when I was a grad student a couple decades ago, we were talking about several hundred kilowatt machines, and we're now talking about megawatt machines. And we have places like Denmark and like Portugal and Texas that have a real shot to be 20 or more % wind, i.e. to get on what's the federal roadmap for wind. So as a industrial system, that one is certainly one that's a real favorite. But at the other end of the spectrum, distributed solar is maybe my favorite story. And in fact, where I do a lot of work in Kenya, rural solar is the largest form of new electrification. Now, it's not cheap, but it is the largest growing source. And that's one that's been done without subsidies, really without a technology well adapted to the market, because it provided a better service. And so I really like this very small scale end as well. But I think the real story for renewables is we need all of the above, not one or two success stories.
Okay. Any last words you'd like to leave the chemical engineers of the world with?
I'm just pleased there's communities of people who are working on everything from synthetic biology to energy storage to novel materials, so that I would like to see one of home I live in the future have organic solar cells that grow on the surface of the home, and that's a wonderful chemical engineering, organic chemistry problem yet to be cracked.
All right. Thank you very much.
Pleasure. Thanks a lot.